Hey everyone, speaking with us today is Jacob George, director of the Utah Neurorobotics Lab and an assistant professor in the Department of Electrical and Computer Engineering and the Department of Physical Medicine and Rehabilitation at the University of Utah. Professor George, would you like to tell us a bit more about your background in research?
Yeah, so thanks for having me here. Yeah, I'm at the University of Utah, and we are working on some really cool cutting edge applications. So brain-machine interfaces, intelligent robotics, deep learning, machine learning, all sorts of hot buzzwords you might hear. And it's really kind of at the intersection of electrical and computer engineering, as well as physical medicine and rehabilitation. So what I'll do today is give you a little bit of background about my research and my journey, and then I'm happy to answer any questions you guys have. But hopefully what I can do is convince you to apply to the University of Utah and convince you to apply to electrical and computer engineering in particular. So without further ado, my lab is called the Utah Neurorobotics Lab. We are working on brain-machine interfaces to enhance human function. We use a combination of three different areas. So the first is assistive and rehabilitative robotics. So we use things like powered arm orthoses or exoskeletons that can help a person who's paralyzed move again, as well as advanced bionic arms or hands that can be controlled by thought and even give a sense of touch back to a user. So that interface of these robotic devices with a human is what we call a neural interface, or sensory motor neural engineering is kind of the discipline. And we use non-invasive approaches like electrodes that interface with the electrical activity of the nervous system, as well as invasive devices that might be implanted in someone's brain or nerves or arm muscles. And we link those two things together, the robotic device and the brain machine interface, using what we often call as bio-inspired artificial intelligence. So we use deep learning, we use machine learning, artificial intelligence, and we also base those artificial neural networks and other things of that sort off of the way that we observe the brain behaving in real world. So I'll start by playing this video here, which kind of highlights one of our key contributions that we put together recently, which if you haven't seen, there's a large media splash we had a little while back, which was focused on what we called the Luke arm. And so what we did is we developed a bionic arm that was directly interfaced with a human brain so that an amputee, a person who's lost their limb, could directly control this with their sense of thought. So they think about moving the hand moves. And then when that hand makes contact with an object, this is the really cool part, is when it makes contact with an object, they actually get a sense of touch coming back so they can actually feel what this device happens. So the idea is that it's truly like a Luke Skywalker arm, that when someone loses their limb, they can have a replacement that is unable to be distinguished from a real limb. So I'll play this video. Hopefully you can hear the sound and it plays smoothly. So as you can imagine, this is really impactful work that can ultimately allow patients who have suffered a life-altering disability like an amputation to complete more dexterous and more useful tasks in their real-world environment. And as best put by one of our participants, one of the amputee individuals we were working with, they said that, quote, "It will soon be just like Luke Skywalker, and soon everyone will want one." And so, as you might think, this is exactly what we're working on. The idea is that we can bring this technology to anyone, so that anyone essentially can become a Jedi mind trick person, a Jedi you can control different devices based strictly on their thoughts. And so the idea here is that your Apple Watch or your Android Watch or whatever you have would detect electrical activity coming from your forearm. We could then decode that activity coming from your forearm into your intent of what you're trying to do. That could be transmitted into a wireless smart home system, and then that could be used to control a device in your home without actually making physical contact. So this could extend beyond, smart home devices, but also into virtual reality. So you can control virtual reality systems just using your hands, or you can control augmented reality systems using your hands as well. There's a prototype of what the device we're working on the left there. But we're really excited about this because it will unlock a bunch of different capabilities that, started as a way to give help to individuals who have lost neuromuscular function, but can also be expanded into patients or the general public as well. And so to that, I'll also point out that, the people who will really benefit from this technology the most are probably the individuals who are suffering from life-altering neuromuscular disabilities. And so this is just an example of the building that I work in at the University of Utah. It's a beautiful campus. We're surrounded by mountains. You can go to like 7 different ski resorts in 30 minutes. We have a nice big downtown city where you can get and do pretty much anything you could imagine. And there's a ton of great outdoor activities and a population of people here that are really just kind of a mecca of industry, as well as a nice hospital community where there's a lot of patients coming in. So you'd have direct access to work with all these different people together. And in particular, in this hospital, we have a new state-of-the-art facility that allows us to help people by monitoring the way they walk. We can monitor their muscle activity. We have devices implanted in their brains as well as in their arms and nerves and spine. We can monitor activity. We can use it to control devices like powered wheelchairs or exoskeletons, as well as to drive stimulation of their arm nerves or muscles to help them walk again if they're paralyzed. So really doing a bunch of different cool projects with brain-computer interfaces directly with patients in a state-of-the-art facility. One of the projects that I think is particularly interesting and very in line with the way that we do things in Utah is a lot of the patients are interested in getting back into recreation. So if an individual has a spinal cord injury, meaning that they're paralyzed potentially from the neck down, then they typically have to move around in a wheelchair using what we call a sip and puff controller, which is pictured here on the right, this little orange thing coming into their mouth. They would basically breathe out. So they would produce a puff of air, and that puff of air would basically turn their wheelchair to the right. Or they could sip in, and that sip of air will turn their wheelchair the other direction. So basically they can use this device to get around in the real world. And that's basically the level of control they have, which is obviously prohibitive. One of the really cool things that we've done in Utah is we've allowed them to use that technology to get back into the outdoors. And so we have this awesome program called the Trails Foundation and a company here called Tetradapt, where they make adaptive recreation for individuals with very challenging disabilities like spinal cord injury. And so in this case, this individual is skiing and they can ski to the left or to the right using this sip and puff controller. But wouldn't it be awesome if they could control this device instead of using sips and puffs of air, but that they could instead control it simply by thinking about it? So that's actually what we did, is we worked with a participant, an individual with spinal cord injury, and we tested out some of our technology with him to allow him to control these devices strictly by thought. And this video talks a little bit about what this individual has to say. And so you'll see we have these different devices placed all over him, and you can see the sip and puff controller in front of him. And what you'll get to see is his reaction to using this technology immediately after. And this is what he had to say.
Well, I'm more excited about this than honestly anything that's happened since I broke my neck. Using a sip and puff to ski was amazing, but with these controls, I could go back to skiing what I used to ski. Like difficult, fine controls. Right now we just have like left turn, right turn, wedge, unwedge. I mean, 10 degrees of freedom, I could just imagine anything
So as you can imagine, this was pretty inspirational for this person, but it was also inspirational for us. He talks about how he could control pretty much anything using this type of technology, and that's really where we want to go. Often using these types of implanted devices to allow people to interact not just with assistive technology, but the world around them, whether it's in virtual reality, physical reality, augmented reality, anything like that. So with that, I'll thank you all for having me and for listening, and then I'll take any questions you have. And I'll just do another reminder that my lab is always inviting new students to come and join. We do have summer programs for high school students. We also are always bringing in new undergraduate researchers from the University of Utah, as well as students that are studying at other universities can also apply and come to the summer programs. But I would highly encourage you to check out the Utah Neurorobotics website at the bottom here, as well as the ECE website, which talks about how you can apply to the program and get involved. And hopefully you can put the University of Utah on your radar, because it really is an awesome place where we're doing cutting edge research in a really beautiful and growing environment. And if you have family still in California, it's a very quick and easy 1 hour flight back and forth, or depending on where you're at in California, it can be a pretty easy drive as well. So with that, I'll end and I'll take any questions you have.
Thanks so much for presenting, Professor George. So I have a couple questions here. So the first question I have is, what inspired you to be a STEM mentor?
Yeah, so when I went to school, I remember being in high school and thinking about what I wanted to do. I remember reading about brain-computer interfaces in particular and thinking, wow, that's a really cool topic. And that was about it. I knew I liked math, and I knew I liked biology. And so I kind of thought maybe I'll do biomedical engineering or something along those lines. And when I came into a program, I actually started off in biomedical engineering, and I very quickly fell in love with my computer science and my electrical engineering courses. So building software, building devices, and seeing the impact that it has right away. So I really fell in love with that aspect. And then I decided to get involved in research and try that out. And when I was in research, I really just enjoyed being able to work with patients, see the impact of what I was doing, as well as to be really on the cutting edge of the technology and what was happening. So for me, I knew I liked math, I knew I liked science, I wanted to help people, and so I got into it just because of the way that I thought things were cool and reading about popular science things, and then it just really resonated with me as I was doing it, and so I decided to stay in that area, and hopefully you guys have a great experience like that as well.
So the second question I have here is, what drives you to develop your Luke prosthetic arm, and what challenges have you encountered in the process?
Yeah, so we really set out to build this because it was a current need of patients. So if you look at what currently exists for individuals who have upper limb loss, the technology is sadly, the current technology is about the same as it was after the American Civil War. So a really long time ago, what happened after an amputation was you'd get a metal hook that was basically controlled using a rope that was tied to your shoulder. So you move your shoulder and that would cause your hook to open and close. And that's actually what people still use today. About half the people using prosthetics use a system that's just like that. So what we wanted to do is make it so that it could be more dexterous, so that a person could control things just simply by thought, and they could do this in a way that was intuitive and do it in a way that would allow them to manipulate objects. And what we found was that it's not so easy to just control an object or control a device without having a sense of touch. And so what we found is that the sense of touch and your ability to feel things is really what regulates your force. So you wouldn't know how hard to squeeze a person's hand or pick up an object without breaking it unless you were able to feel that sense of touch coming back. And so integrating these different devices and pieces was really kind of a key challenge. And across the world in general, there's been a big push for people to not just be very sub-discipline experts. So you don't want you to just be really good at computer science or really good at engineering or or really good at philosophy, right? You need to be a person who can integrate multiple disciplines and solve really big problems. And so that was a key challenge in our group, is that we work with really interdisciplinary people. We have to bring them together and we have to solve this problem from many different facets. And so that would be probably the biggest challenge.
So the third question I have here is, how can high school students get involved with AI and biology research?
Yeah, it's a great question. So I would say one of the most valuable things that you can do, which exists all over the country, is join a robotics club. Robotics clubs are awesome ways to get involved, and robotics is one of those fields that is very interdisciplinary, and it can definitely get you integrated with the hardware side, the software side, as well as the machine learning and all these different components. That would probably be the best way to get involved in AI. In biology, there's all sorts of different ways, but one of the best things you can do as a high school student is to shadow in a hospital as well. So a lot of times there's assisted living facilities, there's nursing facilities, there's hospitals. You can get involved in those. And you can spend some time as a volunteer on these community projects, and that will help you kind of get in touch with what patients need and how you can help them. And so maybe not so much biology, but it's very relevant to medical applications, which is kind of where my focus has been. And so I would say they're two great programs. And the truth is you learn a lot of stuff in school and you'll learn a lot of stuff in college, but there's so much information out there. Like you guys are all probably experts at going on YouTube and finding a video on how to do something and figuring it out. And so these days, if you're interested in trying something, just go online and Google, how to play around with a Raspberry Pi or an Arduino Uno or these types of machine learning embedded systems, or how to practice these things. And there's all these tutorials out there online that you can start playing around with. And the best thing is when you apply to college or you apply to jobs or wherever you might be, you can list these on your resume, right? You can say, hey, I've built an app before, and I've volunteered at a hospital, or I've done these things, and all of those will help really make you integrated into it, and then you can kind of leapfrog from there into bigger and better things.
So another question I have here is, what is one piece of advice you have to give to aspiring engineers early in their careers?
Yeah, so I would encourage people to apply to a broad amount of programs, get some diversity in what you're doing, and get involved in research early on. So it can be a great experience to branch out and try new things in new areas. And getting involved in a research experience early on can really set a trajectory for applied skills. So oftentimes you'll hear people go to college, or even in your classes, I'm sure you experience this sometimes, where you learn a series of math equations or you learn how to do something, but you don't really understand the full picture of it. Like, when am I going to apply this? When is this actually going to be relevant? Or you learn about how a cell, does something in biology, but like, what is the practical application of learning that? And so the way that you can do this effectively is to get involved in a research setting really early on. And so in Utah, we have our high school students partner with the universities, and they actually get to get hands-on experience doing research. And the undergraduates, when they join, there's these awesome initiatives where they have these undergraduate research scholars and engineering leads, where people can come in with scholarships and get directly involved in a lab. And as a freshman, they actually work on a senior design project. So you start working with people who are 4 years, 5 years older than you, doing great research with a company, and you also are in a lab doing research with a professor who's developing cutting edge technology. So there's these awesome programs that will get you right involved. And so every time you learn something in a class, you don't have to think about, where would I actually be using this one day? You're actually using it, right? And every time you learn something, you can take it right back into your lab or take it to your senior design team and build the device and input those things directly into practice. So just to summarize, I think the right way to do it is to get involved with practical applications early on. And an excellent way to do that is through research. And if you're interested in applying to University of Utah. There's a lot of avenues in which you can do that at the University of Utah.
So the final question we have here is, what do you envision the future of neuroengineering to be in the next 5 years?
Yeah, so 5 years is an interesting timeline because in 5 years, I think what you will see is a lot more companies working in this space, and you'll start to see some really cool applications and clinical applications of invasive devices. So I can think of two big things that I think will happen in 5 years. I think you will see companies like Facebook, which now Meta, they have a program where they're using electrical interfaces with the body to basically allow you to interact in virtual reality. I think that will become very big in the next 5 years or so. People will start to use those technologies more. I also think that you will start to see some implanted devices in people's brains that are actually being used in a clinical trial way. So there's already people who are using devices implanted in their brain to do research, but I think we'll actually see a clinical device that patients who have severe spinal cord injury or locked-in syndrome where they can't move, and they'll be able to use these devices. So 5 years is a pretty short time, actually, if you think about the way technology develops. But if you're thinking about even beyond that, right? So let's say in 5 years, you're in college now at this point or so, you're finishing up, maybe even in 10 years, you've kind of started your first job, or maybe you went on to graduate school or medical school or whatever it might be. And in 15 years, you're really kind of at the very, strong portion of your career, right? And in that time frame, I think you will see a lot of really interesting stuff happening. I think you will be seeing, more devices and more applications. So beyond just what we call like neurorobotics, so thinking about controlling devices and interacting with devices, I think you'll see a lot more what we call bioelectronic medicine. So instead of taking a pill that targets kind of systematically across your body, you would be taking a targeted treatment that would basically have some sort of bioelectronic way of interfacing with the body. So it could be stimulating your brain in a certain area to help cure obesity or addiction or pain, all sorts of different things like that. So bioelectronic medicine, I think, is going to blossom. That's going to be a very big market for people who are interested in electrical engineering, computer science, medicine, anything like that. And then I think you'll also see a lot more applications of things in terms of assistive technology. So I think you will see commercial exoskeleton devices that can help you run faster. So your shoes already are a great example of something that can help you run faster, right? But we're going to see things that are powered. They have batteries in them. They have sensors in them. They have motors in them. They can make you run faster. They can help you walk faster. They can track how fast you're running, things like that. And I think these technologies will get more and more common across people. So I think the future in this area is really, really bright, and there's a lot of cool things that are going to be happening. And what I see a lot is people get really excited about AI and technology. And a lot of times they go into, computer science thinking, oh, computer science is, the area that I want to be because that's where AI is. But it's interesting that, electrical and computer engineering is really where a lot of that work happens as well. So AI is a lot embedded into electrical and computer engineering. And what we're currently seeing in the marketplace is that computer scientists are, a ton of them. There's a bunch of people getting computer science degrees. There's not so many people getting electrical and computer engineering degrees. You can imagine with all these computer people trying to program computers, we actually need people to build computers and build devices. And so electrical and computer engineering is one of the highest, it actually is the highest paying salary right now for jobs, at least in Utah. So there's a great employment outlook, and it's a great opportunity to get involved in some of these cutting edge areas and really have more opportunities. So hopefully I've at least kind of sold you on the idea of looking into some of these electrical and computer engineering programs. In particular, I think the University of Utah is an awesome place.
Yeah, well, everyone, thank you so much for watching our interview with Professor George. Take care, and we'll see you all next time. Bye.